Got it? Okay. All right, this is lesson 6.5, and we're going to do problem number 8 on page 329. It says first of all, here's the directions. Assume the sample is taken from a large population, and the correction factor can be ignored. We're going to talk about what the correction factor is tomorrow, so don't worry about that for today. But here's the question. A survey found that the American family generates an average of 17.2 pounds of glass garbage each year. So they went out and surveyed a bunch of people, and we're assuming that this is a normally distributed distribution. And they found that the average amount of glass garbage, so you know, your baby food jars, your spaghetti jars, whatever, the average family uses 17.2 pounds per year of glass garbage. You know, you hear things about when our landfills are going to be full, that type of thing. You know, that comes from people doing surveys like this. Assume the standard deviation of the distribution is 2.5 pounds. Standard deviation, 2.5 pounds of glass garbage. Find the probability that the mean of a sample of 55 families will be between 17 and 18 pounds. So let's say here's 17 pounds will be to the left of 17.2 pounds. 18 pounds will be to the right. Normally, this horizontal axis is our x-axis. Normally, x would be 17 and x would be 18, and we use that to calculate two different z-scores. Here's the thing that's different. We didn't say that we're not finding the probability of a family having between 17 and 18 pounds of glass garbage. We said, what if we go out and sample 55 families, and we want to know what's the probability that that average, the average of those 55 families, that average would be between 17 and 18. So 17 and 18 don't represent one family's garbage, they represent the average of 55 families. So these aren't really x's anymore, these are x bars, they're averages. And our n, our sample size, is 55 families. So when our x-axis, or not our x-axis, when our horizontal axis is now an average axis, it's not an x, it's an x bar average, we can't use the formula we've been using. We normally use x here, instead we need to use x bar. Okay? And we can't use our normal standard deviation, our population standard deviation, we have to use a different expression on the bottom. And this part down here, I'll talk about this more later, but this is called the standard error of the mean. And I'll talk about what that represents more. I want us to see how to do the problems before I get into the, you know, what everything is.
Alright, those formulas going to be on the test too?
Actually, those formulas are on your formula sheet. So you might want to take out your formula sheet, which is on the back of your assignment sheet. All those formulas are on there. So what I'm going to do is find my z-score, and now I'm trying to find the probability that if you randomly select 55 families and find the average amount of glass they use, I want to know the probability that it'll be between 17 and 18 pounds. So to find my z-score for 17 pounds, I plug in 17 for x bar, right there, minus my mean, which is 17.2 pounds, divided by the standard deviation divided by the square root of n. The standard deviation is 2.5 pounds, divided by the square root of, what would be my n in this problem?
55 families.
55 families, yeah, n is 55. Now, if you want to type that expression in your calculator all at once, you can do that. Just make sure you put parentheses around the numerator, parentheses around the denominator, and you also need parentheses around the denominator to get the square root of. So if you want to go ahead and type that in, you can get your z-score for 17 pounds of glass garbage. It says negative 0.59. Yep. Anyone else get that? Okay. If you couldn't get negative 0.59, you're going to want to have me come to your desk and show you how I got that. All right. Next, let's find the z-score for 18 pounds of glass garbage. Now, if you already have this typed in, you can just put a second enter. It should bring that back up, and you can change the 17 to an 18. That'd be the quickest way to do it. Otherwise, you'll have to type the whole thing in again. 18 minus 17.2 divided by 2.5. Square root of 55. Again, if you're going to type it all in one expression, make sure you put parentheses here and here. And here.
2.73 or 2.37.
2.37. 2.37, okay? So what that's telling me is that 18 pounds of glass garbage is 2.37 standard errors. The standard error is kind of like a standard deviation. I'll get into more later about that. 2.37 standard errors above the mean. So 17 is 0.59 standard errors below the mean. 18 is 2.37 standard errors above the mean. Now to get these two areas, we'll go to our z-chart. Get your z-chart out. And you go to 0.5 down the left side, 0.09 along the top. You look over, you look down, and whatever this number is here will give us this area that's to the left of the mean.
0.2224.
Okay, 0.2, sure, 2. So this area between z equals 0 and z equals negative 0.59 is 0.2224. And then for the 2.37, you go to 2.3 along the side, 0.07 along the top, look over, look down. That's a bigger number, I bet.
0.4911.
4911. And then what would we do with these two numbers? Right, add them together. That would give us the total probability that if you surveyed 55 families, that their average amount of glass garbage would be between 17 and 18 pounds. What's that, 0.7135? Sound right? If you add these two numbers together, you get 0.7135, which meaning that there's about a 71% chance that that would happen.